Hello, let us start our fifth module. It's about adaptive neurofuzzy inference systems, ANFIS. So, ANFIS is a class of adaptive networks that are functionally equivalent to fuzzy inference systems. Adaptive networks that are equivalent to fuzzy inference systems. So let us see fuzzy inference systems. We have already studied about fuzzy inference systems. The fuzzy inference system is a popular computing framework based on the concepts of fuzzy set theory, fuzzy if-then rules, and fuzzy reasoning. So let us see the block diagram of a fuzzy inference systems as we have already seen before. This is the block diagram for a fuzzy inference system. It checks input as crisp or fuzzy, and it uses n number of rules, rule 1, rule 2, etc., rule n, and the output produced from these rules are combined by using the aggregator, and it produces fuzzy output. If the system needs a crisp output, then we can defuzzify the fuzzy output. Okay, so that is about fuzzy inference systems. So fuzzy inference systems are of different types, and we have studied mainly three types. They are Mamdani fuzzy inference systems, Sugino fuzzy inference systems, and Tsukamoto fuzzy models. Okay, so next let us see what is an adaptive network. So we told that adaptive networks that are functionally equivalent to fuzzy inference system is ANFIS. Okay, so what is an adaptive network? An adaptive network is a network structure whose overall input-output behavior is determined by a collection of modifiable parameters. Okay, so let us see an example for adaptive networks. So this is an example for adaptive networks. It has different types of layers, and it has two types of nodes. One is fixed node and the other one is adaptive node. So adaptive node has modifiable parameters, and fixed node has only a fixed function. Okay, see this how these nodes are represented. See here, first one is y is equal to f of x, and x is the input, y is the output, f is the given function, and it uses a parameter a. So we can represent this as y is equal to f of x comma a, whereas a is the modifiable parameters. Okay, in the third figure, u is equal to g of x comma a, and v is equal to h of y comma a. Understood? So in this way we can use the nodes in an adaptive network. Okay, and there are two types of adaptive networks: feed forward and feed backward. In feed forward networks, all connections, see this figure, all connections are from left to right. So this type of network is known as feed forward adaptive network. So let us see one feed backward network. See this is an example for feed backward network. See the connection from 8 to 3. Okay, so this type of connection is known as feed backward. And if there is any cycle in this network, then that type of network is known as recurrent adaptive network. Okay, so feed forward and feed backward network. So that is all about adaptive networks. Okay, so ANFIS. Again, ANFIS is a class of adaptive networks that are functionally equivalent to fuzzy inference systems. Next, let us see the ANFIS architecture. Okay, so we are creating an adaptive network for the given fuzzy inference system. Here we are going to use Sugeino-fuzzy model as our fuzzy inference system, and we are creating an adaptive network by using this Sugeino-fuzzy inference system. Okay, so here we have two rule fuzzy system. So rule 1 is if x is a1 and y is b1, then f1 is equal to p1 x plus q1 y plus r1. Rule 2 is if x is a2 and y is b2, then f2 is equal to p2 x plus y q2 y plus r2. So the corresponding representation for this is, see this. So this is the representation for two input first order Sugeino-fuzzy model. Okay, so this is a two input Sugeino-fuzzy model with two rows, and it produces the output f is equal to w1 f1 plus w2 f2 divided by w1 plus w2, where w1 and w2 are the weights in the network. Okay, and f1 is p1, as told earlier, f1 is equal to p1x plus q1y plus r1, f2 is equal to p2x plus q2y plus r2. Okay, so let us see the corresponding adaptive network. So equivalent ANFIS architecture. Here we have two inputs x and y. In layer 1 we have four fuzzy sets a1, a2, b1 and b2. So these are all also known as linguistic labels. We can represent these as the linguistic labels such as small or large, etc. Okay, so in this each node has a membership function mu a1, mu a2, mu b1 and mu b2. Mu a1 of x, the output of node a1 is mu a1 of x, and the output of a2 is mu a2 of x, and the output of b1 is mu b1 of y, and output of b2 is mu b2 of y. Okay, and this membership function can be of any type. Here we normally we are using a generalized bell function. Okay, so the output of first layer is output of a membership function, and in layer 2 is used for multiplying the inputs, and these nodes are fixed nodes, and it is represented by using the pi symbol. So w1 is equal to mu a1 of x into mu b1 of y, and w2 is mu a2 of x and mu b2 of y. So this product of these inputs are w1 and w2, and for normalizing the weights we are using the layer 3. Okay, layer 3 is represented by using the capital symbol n. So w1 bar is equal to w1 by w1 plus w2, and w2 bar is equal to w2 divided by w1 plus w2, that is normalize this weights. Okay, and in layer 4 here we are using the function which is produced by the Sugeino-fuzzy model, which is a quadratic equation. Okay, p1x plus q1y plus r1 and p2x plus q2y plus r2. Okay, so f1 is equal to p1x plus q1y plus r1, and f2 is equal to p2x plus q2y plus r2, and these values are summed up in the last layer 5. So this is summed up, that is w1 bar f1 plus w2 bar f2, that is the value of f. Okay, so that is the value of f, which is the output we have seen for Sugeino-fuzzy model. And there are parameters we are using in layer 1 as well as in layer 4. the parameters used in layer 4 is known as consequent parameters. So what we have done here is we have constructed an adaptive network for the corresponding to input first order Sujinov-Fuzzy model. So this is an example for ANFIS. Okay, thank you.